Regarding the disconnecting means for an air conditioning unit, the National Electrical Code does not specifically mandate the use of a ground bar. However, local inspectors or utility companies monitor such a requirement. The National Electrical Code Section 440.14 does state that the disconnecting means must be capable of disconnecting all ungrounded conductors. A ground bar simply offers a convenient and secure way to achieve this. As for wire color and size, the National Electrical Code doesn't stipulate that wires smaller than number 8 must be gray. It does, however, have clear guidelines on conductor identification. Phase conductors must be identified by colors other than white, gray, or green, as specified in National Electrical Code Section 200.6. Neutral conductors, on the other hand, must be identified by white or gray, also according to National Electrical Code Section 200.6. Equipment grounding conductors must be identified by green or green with yellow stripes, as outlined in National Electrical Code Section 250.119a. Consequently, using gray as a phase conductor is not permissible for wires of any size. In reference to mechanical lugs, National Electrical Code Section 110.14 allows their use for terminating conductors and disconnect switches, but the lug must be designed and listed for the specific application and installed per the manufacturer's instructions. On the subject of ground bars, National Electrical Code Section 250.28 ATWA permits their use to connect grounding conductors. Therefore, to summarize the key points, firstly, always verify local requirements with your inspector or utility company. Secondly, understand that the National Electrical Code mandates specific color codes for phase, neutral, and grounding conductors regardless of wire size. Thirdly, mechanical lugs are acceptable when properly listed and installed. And fourthly, ground bars are a permissible method for connecting grounding conductors as per the National Electrical Code. It's essential to consult the latest edition of the National Electrical Code and any local amendments to ensure compliance with all applicable regulations. The specific sections mentioned, such as 440.14, 200.6, 250.119a, 110.14a, and 250.28 ATWA, are crucial references for electrical installations. Always prioritize safety and accuracy in electrical work by adhering to these codes and best practices. The integrity of an electrical system hinges on proper conductor identification and secure terminations. Furthermore, the use of approved materials and methods ensures long-term reliability and safety. Staying updated with the latest code revisions is a continuous responsibility for electrical professionals. Consider, for instance, the importance of using appropriately rated lugs for the intended application. A lug that is not properly rated for the conductor size or the environment in which it is installed can lead to overheating and potential failure. Similarly, the correct installation of a ground bar is critical for maintaining a low impedance ground path, which is essential for safety and the proper operation of electrical equipment. Always follow the manufacturer's instructions when installing these components. The proper selection and installation of conductors also plays a significant role in overall system performance. For example, using the correct wire size for the ampacity of the circuit is crucial for preventing voltage drop and overheating. National Electrical Code Table 310.16 provides guidance on the allowable ampacities of insulated conductors. In addition to these technical considerations, there are also practical aspects to consider. For example, when working in a confined space, it may be easier to use a ground bar than to individually terminate multiple grounding conductors. Similarly, when working with large conductors, mechanical lugs may be the only practical option for making terminations. Regardless of the specific situation, it is always important to prioritize safety and to follow all applicable codes and regulations. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using properly insulated tools. It also means being aware of the potential hazards of electricity and taking steps to avoid them. By following these guidelines, you can help ensure that electrical work is performed safely and correctly. In addition to the points already covered, let's delve deeper into the nuances of conductor identification. The National Electrical Code's requirements for color coding are not arbitrary. They serve a critical purpose in ensuring safety and preventing potentially dangerous situations. Imagine a scenario where all conductors were the same color. It would be nearly impossible to distinguish between phase conductors, neutral conductors, and grounding conductors. This could lead to accidental contact with energized conductors, resulting in electric shock or even electrocution. By requiring specific colors for each type of conductor, the National Electrical Code makes it much easier for electricians and other qualified personnel to identify and work with electrical systems safely. For instance, the use of white or grey for neutral conductors provides a clear visual cue that these conductors are intended to carry the return current from the load back to the source. Similarly, the use of green or green with yellow stripes for equipment grounding conductors indicates that these conductors are intended to provide a low impedance path for fault current to flow back to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. The prohibition of using white, grey, or green for phase conductors further enhances safety by ensuring that these conductors, which are typically energized, are easily distinguishable from neutral and grounding conductors. In some cases, it may be necessary to re-identify conductors using color tape or other approved methods. For example, if a circuit is wired using only black conductors, it would be necessary to mark the neutral conductor with white tape and the equipment grounding conductor with green tape. The National Electrical Code provides specific guidelines on how to re-identify conductors in Section 200.7. It's important to note that the National Electrical Code is not the only source of information on conductor identification. Local codes and regulations may have additional requirements. For example, some jurisdictions may require the use of specific colors for phase conductors in different types of systems. It's always a good idea to check with your local electrical inspector or authority having jurisdiction to ensure that you are complying with all applicable requirements. Furthermore, understanding the principles behind grounding is essential for ensuring electrical safety. Grounding is the process of connecting electrical equipment and systems to the earth, which provides a common reference point for voltage and helps to prevent electric shock. There are two main types of grounding: equipment grounding and system grounding. Equipment grounding involves connecting the non-current carrying metal parts of electrical equipment to the earth, such as the metal enclosures of appliances, tools, and machinery. This provides a low impedance path for fault current to flow back to the source, thereby tripping a circuit breaker or fuse and energizing the equipment. System grounding involves connecting one of the current carrying conductors of an electrical system to the earth, typically the neutral conductor. This helps to stabilize the voltage of the system and to prevent overvoltages caused by lightning or other disturbances. The National Electrical Code provides detailed requirements for grounding in Article 250. These requirements cover everything from the size and type of grounding conductors to the methods of connecting equipment and systems to the earth. In addition to the National Electrical Code, there are other standards and guidelines that provide information on grounding, such as the Institute of Electrical and Electronics Engineers Standard 142, Recommended Practice for Grounding of Industrial and Commercial Power Systems, commonly known as the Green Book. This standard provides guidance on the design and installation of grounding systems for a wide range of applications. Understanding the principles of grounding and following the applicable codes and standards is essential for ensuring electrical safety and preventing electric shock. It's also important to regularly inspect and test grounding systems to ensure that they are functioning properly. The National Electrical Code requires periodic testing of grounding systems in certain applications, such as hospitals and critical care facilities. In addition to the technical aspects of electrical work, it's also important to be aware of the legal and ethical considerations. Electrical contractors and electricians have a responsibility to ensure that their work is safe, code compliant, and of high quality. This includes obtaining the necessary permits and inspections, following all applicable codes and standards, and using approved materials and methods. It also means being honest and transparent with customers and providing them with accurate information about the work being performed. Unethical or illegal practices, such as cutting corners, using substandard materials, or falsifying inspection reports, can have serious consequences, including fines, license revocation, and even criminal charges. Moreover, they can put people's lives at risk. It's important to remember that electrical work is not just a job, it's a profession with a high level of responsibility. Electrical contractors and electricians have a duty to protect the public and to ensure that electrical systems are safe and reliable. This requires a commitment to professionalism, integrity, and ethical conduct. In conclusion, navigating the National Electrical Code and applying it to real-world scenarios requires a comprehensive understanding of electrical principles, codes, and best practices. Whether it's ensuring proper conductor identification, selecting the right terminations, or adhering to grounding requirements, every decision must be made with safety and compliance in mind. By staying informed, seeking continuous education, and prioritizing ethical conduct, electrical professionals can uphold their responsibility to protect the public and ensure the reliability of electrical systems.